Okay, more problems from section 4.4, optimization problems, and this is number 8. And it says closing off the first quadrant. You are planning to close off a corner of the first quadrant with a line segment 20 units long, running from A to B. Show that the area of the triangle enclosed by the segment is largest when A equals B. Sorry about that, when A equals B. So here's A, here's B. These are the coordinates. This is my segment, which is 20 units long, so I have a right triangle again. So it's similar to earlier problem we did with right triangles. And here I'm going to keep A. I'm not going to use X here. Could be the x-axis, but this could be A on here, this length here. So this length would be A, this length would be B. And I know that these are segments, this is the length, so these segments are actually related by the Pythagorean theorem. A squared plus B squared equals 20 squared. Now I know that area equals 1/2 base times height, so I want to find the maximum, the largest, let's see, the first quadrant. We want to show that the area of the triangle enclosed by the segment is largest when A is equal to B, so we want to find out what the maximum, well, where the maximum area is as far as the values of A and B. So again, I know that the area of a triangle is 1/2 base times height, so that's 1/2 A times B. But again, now I've got two variables, and I know I'm going to take the derivative, so I need to reduce that. And I'm going to reduce that again by the Pythagorean relationship. Since I know the hypotenuse, I have a constraint on these two values. They have to be related in this very special relationship. A squared plus B squared equals 20 squared. So B squared equals, and 20 squared is 400 minus A squared, so B would equal the square root of 400 minus A squared. So in this formula for the area of a triangle, instead of writing B, what will I write? 400 minus A squared. Now I've got it all in terms of A, so now I can write area as a function of A equals 1/2 A times 400 minus A squared. And I'll take the derivative to find the relative extrema, because I want to see what happens when I have the maximum area. So if I take the derivative, again, it's going to be first, and now I'm going to think of the 1/2 as part of the first. And I know the earlier problem I factored it out, but here I'll just carry it along, and I'll think of it as part of the first term. So first times the derivative of the second. So the first is 1/2 A, or I could have written A over 2, times the derivative of the second, and this is my second part. And I'm going to use my square root, so that's going to be 1 over 2 times the square root of 400 minus A squared, times the derivative of negative A squared, or times the derivative of 400 minus A squared, but the derivative of 400 is just 0. And the derivative of this is going to be negative 2A. Plus the second times the derivative of the first, and the derivative of that is just going to be 1/2. Then I can put the 1/2 out in front, and I can bring this up to the top, because we're going to probably use least powers again. So this is 400 minus A squared to the 1/2, so when I bring it up, it becomes 400 minus A squared to the negative 1/2. These twos cancel, so I've got a negative and A squared. And this is just 1/2 in front, and that's just going to be 400 minus A squared to the 1/2 power. So, moving right along, I notice that I've got common factors of 1/2, a leading negative sign that I could take out, and also I've got these binomial factors that are the same. So what's the least power? Negative 1/2. So I'm going to factor that negative 1/2 out. So that's going to be negative 1/2. So that's going to make this a negative sign. And I'll factor this out. Now remember, least powers, when we factor out, we're dividing. When we divide, we subtract the exponents. So I've got, this is what I'm factoring out, so this is what I'm subtracting. So I've got this term here, this first part here is going to be the A squared, and this is going to be negative 1/2 minus negative 1/2, which is negative 1/2 plus 1/2, which is 0. Anything to the 0 power is 1, so this is all going to be 1. So I just have A squared times 1. Okay, the second term, I factored out a negative sign, so that becomes that positive, goes to a negative, because I took out a negative. And I took out the 1/2. And then I've got this 400 minus A squared to the 1/2 minus negative 1/2. Well, that's going to be like 1/2 plus 1/2, which is 1. So that's just going to be that to the first power, which is just 400 minus A squared. Then I look inside here. This is going to be A squared minus 400 plus A squared. So I suggest you do something like this just in case, so you don't mess up on your negative signs here. because sometimes we miss that when we have a negative sign in front of a binomial. Okay, so now I can simplify this more, and we'll make it into a fraction because we're going to try to take the derivative, and that's, or evaluate the derivative, pardon me. So I'll put this on the bottom, so that becomes 400 minus a squared to the positive 1/2 on the bottom. I have a negative 1/2 there, and then this was just going to be 2a squared minus 400. Okay, now 2 goes into 2, and 2 goes into 400, so that's going to be 200. Well, that's going to be a squared minus 200. But then if I have a negative sign, I can multiply and reverse those, so that's going to be positive 200 minus a squared. So we can simplify this to be this. I know I did kind of skip a step, kind of work that out in my head. I hope that's okay. Otherwise, you can add an extra step just to play safe. Okay, so now I want to check, where is this going to be undefined? Well, it's going to be equal to 0 when a squared is 20. And I don't know if I stated that up at the beginning. If I didn't, shame on me. What's my domain? Yeah. A's got to be less than 20 because any side of a right triangle has got to be less than the hypotenuse, and B has got to be less than 20 for the same reason. It can't be equal to 20. A side can't be equal to the hypotenuse. You wouldn't have a triangle. And the hypotenuse is always the longest side of a triangle. So this won't work, so I don't have any place where it's undefined. A cannot be 20. So, but can this be 0? Well, it can be 0 when the top is 0. Now remember, the bottom will always be positive, so I just have to worry about the top. So I set the top equal to 0. Well, actually, that's just, I'm just checking to see when it's 0. It's only going to be 0 when the top is 0. Okay? So 200 minus a squared equals 0. A squared equals 200. A equals plus or minus the square root of 200. Well, we're just going to be dealing with the positive values. It's a length. And that's the same thing as 2 times 100. The square root of 100 is 10, so 10 times the square root of 2, so that's a. So I put this in my derivative test just to check to make sure it's the maximum. 10 times the square root of 2. Now the square root of 2 is 1.414, so 10 times that would be 14.14. 1.414. And then I check 10. And if I put 10 in here, now like I said, if I'm just working about my signs, I don't worry about the sign on the bottom, it's always positive. And 200 minus 10 squared is 100, so that's positive. And if I put 15 in here, this would be 225. 200 minus 225 is negative. So I got positive to negative, increasing to decreasing. So I have at 10 times the square root of 2, I've got a relative maximum, so that's going to be my maximum area. And I just want to show, I'm not too worried about what that is, I just want to show that that's going to happen when A equals B. So this is A. What is B? Well, if I go back up here, I remember B, go all the way back up here, and B was equal to the square root of 400 minus a squared. So I'll put that a squared in there and find out what B is. So B equals the square root of 400 minus a squared, but a squared, well, that a is this, but remember over here, I had this written down, so it's nice to kind of look at what you're writing down. A squared equals 200. So I can just put, instead of a squared, I can just put 200. 400 minus 200 is 200, and the square root of 200 is also 2 times 100, or is it 10 times the square root of 2, so that's a. So B equals this, and then A also equals that, so A equals B. So we showed when the area is the maximum, A equals B. Hope that helps. Now again, try to think about these and try to get as much out of each of these problems as you can, because this will really help you on everything, and including the AP exam. This kind of thinking is what you have to do on the AP exam.